Welcome back to Programming for Artists. In this video, we're going to look at how to build classes of objects that you might want to reuse. In previous videos, we've looked at the basic components of computer programming: variables, of loops, of conditional statements, of vector lists, of how to build functions. And in this video, we're going to look at how to build classes of objects that you might want to reuse. We've already seen some kinds of objects that we can find information about when we looked at vectors. Vectors are lists of variables that we can do operations to. What I want to talk about with classes is how we can make objects that we can reuse. I did some examples using functions, and in the functions we could say things like make me a cup of coffee and tell that function how many times we want to have coffee made. We can ask how many people want coffee and have an integer returned from that function. And classes extend this idea of having things with more complicated code inside it. And a class is a generic kind of object or a thing. And thinking about objects in computer programming is slightly different from thinking about objects in the real world, but they have some similarities. If I think about, I'm just grabbing all the stuff in the studio right here. What I really want is a whole lot of cars. But if I think about a plate, I can think about a specific plate, such as this one, or this one, which is of the same design, but is uniquely different, or this one, which is of a similar design, but is different. Different diameter, different dish shape, different color. Or this one, which is very similar to this one, but a different size. So it has the same color, it has the same dish, it has the same geometry, but it's a different size. Or this one, again, everything's covered in coffee grounds, which is the same color as these two, but has a different dish to it, but they're all generically plate. And with a class, I can think of these as a class of objects, a type of objects. So it's not any specific one of these, but it's something that they all share that's common. And each individual plate is a specific instance of that kind of thing, that type of thing, in this instance, a plate. So taking that as a not particularly great example, I'm going to leave them there for reference. I could think of a plate as a generic thing. If I said to a factory, I want you to make me some plates. So I want to have a basic design for a plate, and I'm going to say a plate will have a diameter. This is on the basis that they're all round plates, so maybe they're a special subset of plates. It'll have a color and a depth. And let's add one more thing. No, actually, yeah, let's curvature. So this is my plate, and these are the things that are inside the plate. So I'm going to put these into curly brackets, and then I can specify what these things are. Well, the diameter is going to be an integer, and the color is going to be in RGB, and the depth will be an integer, and the curvature will be an integer of specifying representing degrees. So basically here I have a description of what a plate is generically, but it's not any plate yet. But if I describe this as a class of objects, a type of objects, I could say to the program, take this design or this little factory and make me a specific plate with this diameter, this particular odd 1970s color, a particular depth to it, and a curvature at the edge, and give it a name, and that would be a specific instance of this class of plate. And what's cool is that we can design these objects, these classes, types of things, and keep reusing them. So, combining it with things like the vector of lists that we found previously, and also integers of variables, I can make a new type of thing. So I could make a class description for a plate and then just say, make me 1,000 plates. And I could make them all the same, or I could randomize their diameter or their color or their curvature and address each one individually. So if I wanted to make plates, for instance, for my barbecue, I could set a generic pattern for a plate and then make specific instances of them that were named by using this definition of a class of things, a type of things. So that's what classes are, essentially, in programs. Now, depending upon the type of thing you want to build, there's also stuff that they can do, not just be. And I could describe functions or methods that this plate understands about how to do. And we saw functions earlier, like get coffee, make coffee, count people for coffee, etc. And I could say, well, one of the things that a plate can do, it's actually a terrible example because plates can't do very much, is I know what it can do. It can check whether it's got anything on it. So I can say to the plate, what's on you? What's on your plate? So this, we'll call it get contents. And it's a thing that it can do, and it's going to return me a string. God, this is a terrible example. Let's carry on with it anyway and see what happens. So I can say, get the contents of the plate. So when a plate gets made, it knows how to have a diameter, it has a color, it has a depth, it has a curvature, and it has a function or a thing that it can do. So I could say, this specific plate, get the contents of the plate. And what I would do is I'd define how you get the contents of the plate. So now, if I've defined plate as an object, I can say, make me a plate, because the program now recognizes this as the kind of thing that it understands what it is, just like an integer or a variable or a vector. And say, make me a plate called little yellow 1. Bingo. It makes me one plate called yellow 1. So there's a specific instance of the plate, and it has a specific name. Just like the Ford factory would have a template for how you make a Ford Focus or some other truck or some other car. But when one is made, it has a specific registration number, and that is that version of the blueprint for that truck, and there's things that it can do. In this case, little yellow plate, I can say, make little yellow plate, made a specific instance. And then I can say, little yellow 1, which means I'm talking to this specific plate. And let's see the things that it can do. It can have a diameter, a color, depth, etc. I can say diameter, which is a variable inside the little yellow plate, equals 10. So the diameter would be set to 10, and then I could say little yellow 1 dot, what else would it do? Color, depth. And then I'd give it a color value, and I can set the different attributes of that specific instance of my type of thing, the type being a plate. What I can also do is I can ask the plate what's on it, because it's a function or a method that that plate understands how to perform it. So I can say, I'm going to make a variable called stuff equals little yellow 1, so I'm talking about this specific plate, dot, and the method that I wrote was get contents. So a little yellow plate will look inside itself, realize that it knows how to do this function, get contents, go and do it, and put the result into this stuff variable. We're going to program all of this in C, and C++, and openFrameworks, and build up complicated things. But what I've built now is a class of object that can describe a generic set of plates where I can change the diameter, the depth, and the color, and I can give these plates abilities that I can ask them to do on that specific version. And just like I could make my vector full of the names of all the people coming to my barbecue, now that my program understands plate as a type of thing, I could make a vector of plate. So every time I make a new instance of a plate, whether it's large or small or yellow or brown or deep or shallow, I can put it into a vector so I can organize all of my plates into a big list. And I can go through and say, ask each one, find out what's on you. What's great is that the parts of my program that just ask a plate to change its diameter or its color to find out how what contents it's got on the plate is separated from the code that I've written about how it does it. So if I want to go and update and find a new way to get the contents quicker or to add a parameter, I can modify the plate, and as long as I don't remove one of these major bits, the other parts of the program that ask the plate, what have you got sat on you, don't care that the way in which the plate is doing it has changed, which is awesome because it encapsulates and separates all these bits. So that's a really messy sort of introduction to the idea of a generic class of an object like a plate, the way in which you can describe that class of objects to have particular parameters, and also that they can have methods like get contents of things that they can do, and how you can make a specific instance of one, like little yellow one, and set some of the parameters about it, like its diameter and its color, and also run methods or functions that it can do to itself, and it's encapsulated as this object. And what's great now is I've made a barbecue program that describes plates because it knows it wants to use them. That plate, potentially, if I write a program for parties or for a restaurant, I can say, I've already described this plate object, I'll just bring that plate class over and reuse them for my restaurant or for my party or whatever else I may want to. So I can reuse objects, and that starts to happen quite a lot, especially when we start making use of what we looked at earlier, which is libraries that other people have written, that they'll be making these classes of objects that we can reuse as well in our own programs. So, promise, 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 really nearly, that is kind of nearly all you need to know about programming. Variables, libraries that we can bring in of other people's code, we just say which ones we want to use. Conditional statements to say, if this is happening, then do that. Loops to say, count from here to there, going through, doing this a certain number of times. Things like vectors to organize lots of different kinds of variables together. The ability to make functions where we can say, go into the lounge, ask everyone there how many people want coffee, and then come back and tell me the number of that. And then take that number that you found out and make coffee for that number of people. So functions like that. And then we can make classes of objects so we can specify custom things that don't yet exist but we would like to use and potentially reuse, that can have specific parameters about them, their color, their diameter, their depth, and also specific things that they can do. So they can find out what their contents are, or if it was a car, they can find out what speed they are, they can find out how much fuel is in them, and it refers to that specific instance, which suddenly becomes both a little bit mind-bending and really, really amazing, because what we're building is structure out of things that we can start to build amazing stuff that runs fast, working with computers. So if you like the video, if any of this makes sense, please do watch more videos, subscribe, hit the like button, leave comments below. In the next series of videos, we're going to take all of these bits of ideas on paper, of plates, etc., and we're going to start coding them up in C++ and build some art stuff. So I'll see you on the next video.